Yo, 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 Unit 4, Test Review, Part C, here we go. All right. Up first, we got to complete this proof. And it gives us all the statements. We got to give the reason. On your test, you usually have a word bank. I'm sure this test will be no different. X is the midpoint of JK. How do you know? If you don't know, now you know because you read the given information. So the reason is given. All right. So I know that X is the midpoint of JK. JK. And X is the midpoint. So based on that information, you should be able to put some extra markings here. There's something that you know in your brain, your very smart brain. If X is the midpoint, then I know JX is congruent to XK, because that's the definition of a midpoint. So stuff like that, right? Definition of midpoint. I've been trying hard to teach you. Up next, how do we know that JL is congruent to KL? Well, probably because it says right here, JL is congruent to KL. So again, that's given. All right. So up next, what do you know? Well, you might see here that it gives you a hint. LX is congruent to LX, but how is LX congruent to LX? How is anything ever congruent to itself? The good old reflexive property. All right. So now looking at those two triangles, how is this triangle on the left, known as JXL, congruent to this triangle on the right? And you'll see it's because they have one pair, two pair, three pairs of matching sides. Three pairs of matching sides. So they are congruent by side congruence. Very cool. Up next, it says if angle AOB. So the first thing you need to do is find angle AOB. Angle AOB right here. There it is. Angle AOB is a right angle. All right, I'm going to put a little right angle symbol there. And it says CA is congruent to BA. Well, before I go any further, I know if that one single angle is a right angle, then all these little angles are going to be right angles. All right. So I got that. And now it says that CA is congruent to BA. CA is congruent to BA. Then AOC, all right, let's find angle AOC. I'm going to color it green. Angle AOC, triangle AOC. So this green triangle here, oh, let me get a highlighter. So this green triangle right here is congruent to this purple triangle here. AOB, and I need to know why. Well, there's something that I haven't marked yet. Hopefully you're seeing it. We got the reflexive property going on there, dude. We got the reflexive property. Yes, we do. So reflexive property is telling me that that side is congruent to itself. So if I were just looking at this and like, okay, I have one matching pair of sides. Boop, 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 boop. And then the reflexive property pair of sides. And then I know that the two 90-degree angles are congruent. So that would be like SSA or ASS, okay? We're not allowed to have SSA or ASS, so that doesn't work. So your first thought might be that they're not congruent, but they are right triangles. So we have that other theorem that we can use. Instead of thinking about this as a side, let's think about that as the hypotenuse, because it is. It's across from the right angle. It's the hypotenuse. And then this side here is the leg. So if that's true, then I have a pair of matching hypotenuses and a pair of matching legs. So these two right triangles are congruent by HL. Cool. So at first I thought it was SSA or AS, but those aren't allowed. It's definitely going to be HL. which only works for right triangles. And then down here it says if CA is congruent to CD, all right, if CA is congruent to CD, and AO is congruent to DO, all right, so those are congruent, then which triangles are congruent by SSS? Well, I'm going to erase some of this stuff. Hopefully that doesn't mess up other things. It won't let me erase. There it goes. Cool. All right, I know I have the reflexive property going on right here. So with that new given information that they gave me, now I can see that this triangle is congruent to this triangle because they have 3 pairs of matching sides. So I just need to name them right. So triangle ACO. So now I have to go in the right order. If I said A, I'd have to pick the corresponding point to A. So that would be point D. And if I said ACO, then I need to make sure I go DCO so that everything matches up. So triangle ACO could be congruent to triangle DCO by side, side, side. All right, it says identify the criteria by which you can prove each pair of connected or overlapping triangles are congruent. Write a congruent statement for each. Okay. So the first one, we see the reflexive property, so let's mark it. That's all I have. So I have a pair of matching angles because they're both right angles, and I have one side by the reflexive property. Well, that's not enough information. All right, up next, I've got a couple triangles that overlap with each other. So what I'm going to do is I'm going to redraw them. Redraw this guy. The blue one, we'll call it ABC. And we'll redraw this guy. And its name is DCB. All right, guys, and then we also have to draw in all the congruence marks. So I see that angle A has a congruence mark up here, which matches with angle D's congruence mark. Okay, and then I also see that this angle B down here, I should call it angle DBC. Angle DBC has 2 congruence arcs, which matches with angle BCA's 2 congruence marks. So that's all good, but there's something that we need to see here. Hopefully you see it already. There's a place where those 2 triangles overlap with each other. A place where they get, they have that reflexive property going on. And that's side BC. So make sure that you label this side BC is congruent to itself. BC is congruent to BC, thanks to that reflexive property. So now I can say that these 2 triangles, the order matters. So if I say ABC, I've got to have the matching points to that. So angle A matches with angle D, angle B matches with angle C, and angle C matches with angle B. So those 2 triangles are congruent. And if I look at the reason, and we got the 2 angles, angle A and angle C, which match up with these 2 angles. So I've got 2 angles. And then I have to decide, is that side that we see marked up, is this sucker included? Is it sandwiched between the 2 angles? And no, it's not. You should be able to clearly see that that side with the tick mark is not sandwiched between. It's on the outside of the 2 angles. So those triangles would be congruent by angle, angle, side, AAS. Now look down here, the left side over here, we got another pair of overlappers right here. So again, I highly suggest that you redraw these. So I'm going to redraw these. We'll draw one in blue. And its name is ABC. D, E. But what about B? B's not the vertex, so I don't need to draw that in there. And then I'll draw another one in red. A, B, C. All right, so I see my two triangles. I'm going to put all the congruence marks on there. I've got a congruence mark at angle E, which matches with the congruence mark at angle C. I see that BA is congruent to DA. So cool, 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 cool. And now the last thing oh, they already marked it. Those silly gooses. They've already put the congruence mark there. Now, you won't normally have that congruence mark there. Normally, I would be like, all right, class, what's going on here at angle A? And then I'd wait for a student to be like, they're overlapping. It's the reflexive property, something like that. So I need you to be able to realize that angle A is congruent to itself. We call that the reflexive property. So again, I've got these two triangles that are congruent to each other. A triangle ADE. And remember, the order does matter. Triangle ADE would be congruent to triangle ABC. And the reason that is because A matches with A, duh, D matches with B, okay, and E matches. So the order does matter. All right, and the reason we can prove those triangles congruent to each other is by, we have two matching angles, angle, angle, and then the side that's not included, so angle, angle, side. All right, almost done. Wow. Look at us go. Complete the proof, okay? To complete this proof, there's 2 steps left to go. So whoa, pushing buttons here. Step 4, step 5. All right, 2 steps left to go in this proof. All right, what do we got? We have that YW bisects XZ. So given definition of a bisector, I've already taken care of that. Given that XY is congruent to YZ, XY is congruent to YZ. Actually, I'm going to have a 6th step. All right, and that's given. Okay, we got that. Now, here's something that's not given to us. You should see it. YW is congruent to something. Do you know what YW is congruent to? Yes, I do, Mr. Swan. It's congruent to itself. You're very good. Good job, student. What is it? What is the reason why it's congruent to itself? It's the reflexive property. Very good, student. Cool. So now I can say that those 2 triangles are congruent to each other. What 2 triangles? I can say that triangle XYW is congruent to triangle. So if I said XYW, I got to say ZYW would be the matching one. And the reason for that would be, I see SSS. All right, so I proved that those two triangles are congruent, just like we talked about like 2 trucks being congruent or 2 phones being congruent. That means all their parts are congruent. So when we want to know if XYW is congruent to ZYW, well, we know that they're the same triangles, so all their parts are the same. And the reason for that, we call it CPCTC. Corresponding parts of congruent triangles are congruent. Just like when I said, hey, we got this truck over here, and it's congruent to this truck over here. Oops, don't judge me. So if those 2 trucks are congruent, then all their parts are the same. Their wheels are the same. Their muffler's the same. Okay, their headlights are the same. All the parts of one truck are congruent to the parts of the other truck because the trucks are the same. Same thing with these triangles. If those 2 triangles are the same, then all their parts are the same. Just like if I cloned my chickens, then all the parts of the chickens, I don't know. That's getting weird. All right, guys, last one. Classify triangle MNP by side lengths given the following coordinates. All right, so to do this, you would have to use the distance formula. So this one's a lot of work. You'd have to do the distance formula multiple times. So to find the length of MN, you got to find the distance between M and N. All right, I'll do some of this with you, but you got to do the majority of it on your own. So the distance between M and N, I would label it x1, y1, x2, y2, and the distance would be the difference of my x's, so 14 minus 1, the difference of my y's, so 2 minus 2. So the distance is going to be 169 plus 0, square rooted. So MN has a length of 13. Okay, now I can find the length of NP. I'll call this x1, y1, x2, y2. I'll do the same thing. The difference of my x's plus the difference of my y's is x2 minus x1, so 13 minus 13 is 0. y2 minus y1, so it's 7 minus 2, which is 5. So it's 0 squared plus 5 squared. That's just square root of 25, which is just 5. So NP is 5. So then lastly, I'm not going to do this, but you could do it. You'd find the distance between M and P. And if it's 13, then you have an isosceles. If it's 5, you have an isosceles. If it's something other than 5 or 13, it sounds like a scalene triangle, which means none of its sides are congruent. All right, this has become a 17-minute video, so this is where I end. Goodbye.